Okay, we're doing lesson 8-2, which is angle similarity, and this is student journal page 228. So go ahead and open your student journals to page 228. So remember our definition of similar figures is two polygons are similar if they are the same shape but different sizes. So remember, corresponding angles are equal, but the corresponding sides are in proportion. So if one figure is twice the size of the other, the angles would be equal, but the sides would be doubled. And in a similarity transformation, we have a transformation that maps two similar figures onto each other. And one of those is always a dilation. Remember, a dilation is a transformation that changes size. So next we have angle similarity theorem, and we're given that angle A is congruent to angle D. So right here, angle A is congruent to angle D, and angle B is congruent to angle E. So we have two pairs of congruent angles, so I can say that ABC is congruent to DEF by the angle similarity theorem. So why do you suppose just two angles are enough? Well, remember, all the angles in a triangle add up to 180 degrees. So since all the interior angles up to 180, the third angles of each of the two triangles would be equal as well. So anytime you have angle, you really have angle. So it's enough to just have angle. So here we have to determine if the two triangles are similar or not. So here we go. Remember that all the angles in a triangle add up to 180. So I know that this angle is 15 and this angle is 90. So if I add those up, 15 plus 90 is 105. And I subtract that from 180, 180 minus 105, I get that angle C is 75. Well, C is 75 and so is D. So I know that C is congruent to D because they are both 75. Okay, then I have that E is congruent to A because they are both 90. So I have two pairs of congruent angles in one triangle congruent to the corresponding angles in another triangle. So that means the two triangles are similar. So I can say ABC is congruent to triangle EFD. Remember, this symbol right here is a similarity symbol. That tilde, the thing that goes over the N, or ñe in Spanish, that's a similarity symbol. And that would be by angle similarity. So next, I have to show if these two triangles are congruent or not. So again, I need to find the measure of angle E. So to find the measure of angle E, I'm going to remember that all the angles in a triangle add up to 180. And then I can take 44 and 30, and I get 74. And then I can subtract that from 180, and I get 180 minus 74, and I get 106. So I know that angle E is 106. But that's a problem because angle B is 116. So this is 106, but this is 116. So those angles are not equal, so E is not congruent to B. These are equal, but this is not going to be 44, so that means none of the two pairs of angles aren't equal. So I have to say the triangles are not similar because they do not have two pairs of congruent angles. Okay, for number 3, I want to show that these two triangles are similar. So first of all, I want to make sure you understand the two triangles we're talking about. We're talking about the red triangle, ACE, and the smaller green triangle, BCD. So first of all, notice that they have a shared angle right here. Angle C is in the red triangle, and it's also in the green triangle. So this is like a shared side, but this is a shared angle. So I know that angle C is congruent to angle C by the reflexive property. Okay, next I'm going to call this angle right here angle 1, and this angle here angle 2. And I'm going to look at this, and I know that line AE is parallel to side BD. Remember, that's what these arrows mean, so that means they're parallel to each other. So remember, angle 1 and angle 2 are a special angle pair. Are they alternate interior, alternate exterior, same side interior, corresponding? What are they? Well, it turns out that they are corresponding. And we have a theorem that says when the lines are parallel, if corresponding angles are congruent, or if the lines are parallel, then corresponding angles are congruent. So I know that angle 1 is congruent to angle 2. So I have angle C is congruent to angle C, and angle 1 is congruent to angle 2, so I have two angles are congruent. So that's enough to say that the two triangles are similar by the angle-angle similarity theorem. Okay, so one more. Again, I want to show that the two triangles are similar. So I'm going to start by calling this angle 1 and this angle 2. So angle 1, and there's angle 2. And we didn't go over this yet, but there's something that we need to know, and that is in a parallelogram that opposite angles are congruent. So that means that angle P is going to be congruent to angle R because they're opposite angles. So here PQRS is a parallelogram. Opposite angles of a parallelogram are congruent, so that means that P is congruent to angle R. So we have a pair of equal angles right here. And then I know that PQ is parallel to SR, so again, angle 1 and angle 2 are special angle pair. So remember, they alternate exterior, alternate interior, same side interior, or corresponding. And if you remember, these are alternate interior. They're between these two and on opposite sides of this. So alternate interior. And we have a theorem that says when the lines are parallel, alternate interior angles are equal. So I know that angle 1 is congruent to angle 2. So that's enough to say that the two triangles are similar by angle-angle similarity. And that's it.